Finding the area of a triangle is not as difficult as it seems. It is actually the same for any triangle, whether it's right-angled, scalene, isosceles, any triangle, the principle is the same. To help us understand it, we need to go back a step and look at the area of any rectangle or square. And if we know the height and the length, we can do a simple multiplication to find the area of our rectangle. So that would simply be the height times the length. Let's put some numbers into this. Let's consider the height as 10 centimetres and the length as, say, 15 centimetres. So putting that into my formula, that would equal 10 times the 15, and the area would simply be 150 centimetres squared. The units for area, centimetres squared. If I take that same rectangle and I divide it effectively in half from corner to corner, I've created two triangles. And actually both triangles are exactly the same, they are identical. And each of them take up half the area of that original rectangle. Now the original rectangle was 150 centimetres squared, so each of these triangles will be 75 centimetres squared, half of the original rectangle. This example is no different. I've used the same rectangle as before, and believe it or not, the blue triangle takes up half the area of that original rectangle. How can I prove this? Well, if I take the two smaller triangles and place them so that they overlap the blue triangle, we can see that both of them actually match. So, the red bits form one triangle. The blue is obviously a triangle itself, and both of them match. Each of them take up half the area of that original rectangle. This example is even less obvious, but I can take the two red pieces and actually form a triangle which matches the blue. Therefore, each of these will take up half of that original rectangle. So, each of these triangles match, therefore taking up half the area of the original rectangle. So, to apply this to real examples, we need to know both the height of our triangle and the length of it. More importantly, we need to know what we call the perpendicular height. Quite a strange word. Perpendicular height of our triangle. And it's this that pupils often get confused with. Perpendicular means that it's at 90 degrees to this dimension here. And I've shown that by showing the little box here. Original example, we said that our height was 10 centimetres, our length was 15 centimetres, and I proved that this triangle is half the area of that original rectangle. So all we need to do is 1/2 multiplied by 10 multiplied by 15, and that gives us an overall area for the triangle of 75 centimetres squared. In the previous example, it was easy to find the perpendicular height. With this example, it's a little less obvious, but it is at 90 degrees to the length at the bottom, which is where I'm marking now. So that is the height which I am going to use, which is the same as the previous example. Again, it was 10 centimetres, and the length of the base remains the same at 15 centimetres. The more difficult example, well, where is the perpendicular height? Pupils will often mistake it for this side here, the short side here, and try and use that as their perpendicular height, when in fact it's actually from the point at 90 degrees all the way down to the base. Down here. And the dimensions remain the same as with all the other examples. This we said was 10, this was 15 centimetres. Have a go at this example. For the sake of argument, we'll say that the length here is, say, 20 centimetres. But where is the perpendicular height? Put your finger on the screen, pause the clip and see if you can work out where the perpendicular height needs to be. Did you get it right? It's actually from that top point, 90 degrees down to the base. Down to here. For the sake of argument, let's say that we measured that also as 20 centimetres from top to bottom to help us with our calculation. So, we know the length along there is 20 centimetres. We know the height here is 20 centimetres. And I know that half multiplied by 20 multiplied by 20 will give me my area. And I can use my paper calculator to work that out because I'm not testing multiplication skills. And that will actually give us an answer of 1/2 multiplied by 400, which actually in fact is 200 centimetres squared. I hope that helps. Finding the perpendicular height of any triangle can often be the sticking point for many children. And what I advise them to do is, there's nothing wrong in either rotating the triangle around so you can view it slightly better, or indeed the actual full page. A slightly daft way of looking at it is, imagine that this is a pyramid and you're looking at it sideways on. And I often say to children, right, rather than taking the stairs, which is the long and hard way, try and imagine an elevator going right up to the top. So the elevator has to go in a nice straight line from the base, which is from there, and that is my perpendicular height. These two triangles are actually identical in size. Now I could use the right angle here, and this would be its perpendicular height, and this would be the length, so 1/2 times both of those dimensions would give me the area of this. This would have the same area. There's nothing wrong in actually doing it that way. So there's my pyramid. My elevator then needs to go to the top, and believe it or not, using that height and that length would actually give me the same area, the same result.